Almost done?
Yes. I was moving too slow.
All right, so this theorem is actually pretty important. I call it the linear combo theorem, that if you know that D is the greatest common divisor of A and B, then there's going to exist integers so that you can write D as a linear combination of A and B. That's how I think of it. And I'm going to give you one proof, and then we might be out of time. Let's see. If not, I have some nice things up my sleeve. So in number theory, this theorem's used quite a bit. I don't know how much number theory you guys did in abstract algebra. Only Isaac's taken it, but that theorem is actually used all the time. So it seems like a trivial thing. Again, like these subtle things you use in number theory at the very beginning seem like they're not that interesting, and then you start using it all the time, and you realize actually that's pretty important. So a corollary to a theorem is when you have a result to the big theorem that just comes and pops out from the big theorem. So a corollary to this is if I have two integers, I'm just going to put them natural numbers, so I require them to be positive. And I have that the greatest common divisor is D. And I have C belongs to the natural numbers with C divides A and C divides B. I think I gave you this as a definition the other day. I shouldn't have given it as to you a definition. We only know that C is supposed to be less or equal to D. I'm using Underwood Dudley's book. In the definition of GCD. I just think of them as being the same thing because I knew about this corollary already. All right, I'm not going to list out the know and show, but remember, like, whenever I don't list them out, it just gets disorganized. And usually the theorems I prove are not going to be easy. So every time I skip it, it's like 10 pages of scratch work that doesn't mean anything. So the good habits start with writing down your know very clearly, writing down your show very clearly, kind of identifying how to get from your know to show, have a plan, and then put that all together.
Man, could you clarify GCD part 2?
So there was two parts to the GCD. One is that the GCD has to divide A and B, and the second part was that if C divides A and C divides B, then I put C divides D, but it should be C is less or equal to D. It's going to turn out to be one and the same thing. Okay, so I'm going to prove this. So there's my common divisor. Then, by the linear combo theorem, D equals AX plus BY for some X and Y belonging to Z. So again, if you did this, wrote out the know and the show, on the show part, you would have if C divides A and C divides B, that would pop up into your know. So I'm going to put that in my know here. Assume C divides A and C divides B. What do I have to show? Just to alert the reader. Hey, remember, this is what I'm supposed to do. Question? And I'm gonna put a little star here. Totally legit. Got your own proof styles. The reason I had to walk around the class that day is because everybody has a different way of conveying it. But the only requirement is that the reader should understand what you're doing. So even if it's different than somebody else's, as long as the reader understands what you're doing. I didn't do this semester, but I had a faculty member write a proof and I wrote a proof and I showed the class how different they are. But they both had some ingredients that were the same, and that's a checklist. That's where we started coming up with the checklist. Okay, so boom, let's go. By definition of divides. A is equal to C times S and B is equal to C times T, or some S and T belonging to Z. Welcome back. What is it about our class? Somebody always has to be in a sling. We have an existence proof. Okay, then by definition, okay, we have that. And I'm going to box these off and call this star star. Leave it off. What do you feel like doing? Just like autopilot from taking years of high school math. You feel like taking that C out, factoring it just for no reason. Don't abbreviate associative. By the associative and distributive law, which allows me to factor that C out. Then I'm done because Sx plus Ty is just another integer. And by definition of divides, C divides D. I'm recording everything. I'm recording everything. So.
And could you show why you're done?
I'm almost done. Yeah, I want to wait till everybody catches up. So I don't usually write this, but I should. U is an integer. By definition of divides. C divides D. Nice, right? Proofs are nice. I have a Bachelor of Arts in math. As I get a question? Bridget, don't you think this is pretty? A little bit. It's like nice and
That
pat.
makes sense. That's good. I like that.
Good. We've changed her. All right.
Okay.
Number 3.
It's gotta be-
Because they're clean. It's pretty clean.
Really?
So for example, the four color theorem, that proof is not clean. That's like ugly. So, you know, it's case by case. I hate case proofs. They're not pretty. So what I'm thinking of doing